The first thing that you should have done is go into your book on page 440 and done the activity there with your computer using the applet. If you didn't do that, you really need to do that before you watch this video. Okay, so now that you did that applet, let's go through the notes. So how good is the statistic p hat as an estimate of the parameter p? The sampling distribution for p hat answers this question. So this kind of, again, goes through what that applet was talking about. It says, consider the approximate sampling distributions generated by a simulation in which SRSs of Reese's Pieces are drawn from a population whose proportion of orange candies is either 0.45 or 0.15. What do you notice about the shape, center, and spread of each? So there's what came up with the applet. And notice that our sample size changed from each of those, from 25 and then to 50 on the second one. So let's see what that means. Here we have it for the 0.15. And let's talk about what we notice about the shape, center, and spread of each of those. For the shape, in some cases the sampling distribution for p hat can be approximated by a normal curve. This seems to depend on both the sample size n and the population proportion p. For center, the mean of the distribution is mu sub p hat is equal to p. This makes sense because the sample proportion p hat is an unbiased estimator of p. The spread. For a specific value of p, the standard deviation, sigma sub p hat, gets smaller as n gets larger. So that makes sense. The spread gets smaller as our sample size increases. The value of sigma sub p hat depends on both n and p. There's an important connection between the sample proportion p hat and the number of successes x in the sample. P hat is equal to the count of successes in the sample divided by the size of the sample, or x divided by n. This example is one that's already got all the information there. It's just giving you some more information. You should take some time to read through that in your packet. I'm not going to take time in the video to do that, to save some time. In Chapter 6, we learned that the mean and the standard deviation of a binomial random variable x was n times p, and that the standard deviation was the square root of n times p times q. Remember, I called the complement q. Since p hat is x divided by n, or 1 over n times x, we are just multiplying the random variable x by a constant, 1 over n, to get the random variable p hat. So, mu sub p hat is equal to 1 over n times n over p, which is equal to p, which tells us that p hat is an unbiased estimator of p. And sigma is the standard deviation of p hat is going to be, multiply that by 1 over n. So we get the square root of p times q divided by n. As sample size increases, the spread is going to decrease. So here again are some main things. The mean of the sampling distribution of p hat is equal to p. The standard deviation is equal to the square root of p times q divided by n. Again, as long as the 10% condition is satisfied. That means our sample size has to be less than 10% of the entire population. As n increases, the sampling distribution becomes approximately normal. Before you perform normal calculations, check that the normal condition is satisfied. N times p has to be greater than or equal to 10, and n times q has to be greater than or equal to 10, just like before. So if we're looking at this with our values of p hat from our samples along the x-axis, the higher the sample size, the greater the p hat, the closer it's going to be. Okay, so let's put this all into a problem. Planning for college. It says the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a four-year college or university. Problem: what is the probability that a simple random sample of size 125 will give a result within 7 percentage points of the true value? Okay, these are the problems where we have to start using that state, plan, answer, do, and conclude. So we're going to start with that. So for part one, we're going to state what we know. So we want to find the probability that the percentage of middle school students who plan to attend a four-year college or university falls between 73% and 87%. So that means we're trying to find the probability that p hat is between 0.73 and 0.87. The mean of the sampling distribution of p hat, or mu sub p hat, is equal to p, which they told us in the problem was 0.8, 80%. Because the school district is large, we can assume that there are more than 10 times 125. So this is the 10% rule. 10 times our sample size of 125 is 1250. Since it was a large school, we can assume that this is satisfied. Which means we can find the standard deviation of p hat to be the square root of n times p times q. I'm sorry, p times q divided by n. .036. You can check in your calculator if you'd like. Also, we can, because n times p is equal to 100, and that's greater than or equal to 10, and n times q is equal to 25, and that's greater than or equal to 10, we can assume a normal distribution. Okay, so that's just writing down what we're looking for, stating the information that was given, and writing everything down. The only other thing that I believe we should have here maybe is, since we wrote just the word Q, maybe we should put Q as 0.2. Okay, so step 2, now we're going to actually plan and do our problems. Okay, so because we have this probability that we're trying to find, we're going to convert them to z-scores because we can assume that this is normal. So first I'm going to find z, which would be 0.73 minus 0.8 divided by the standard deviation, which gave me negative 1.94. And I'll find z for 0.87 the same way. And I got 1.94. So now we have the probability that p hat is between 0.73 and 0.87 can be changed into the probability that z is between negative 0.94 and positive 1.94. You can use your table or you can use your calculator. I'm using my calculator, so I'm saying on my paper normal CDF, and I have negative 1.94, comma 1.94, comma 0, comma 1. And I got 0.9476. So then finally, our last step to all of this is we need to conclude. I kind of did the plan and the do all at once. So I'm going to add do here. So what we can conclude from this is about 94.76% of all simple random samples of size 125 will give a sample proportion within seven percentage points of the true population. Not population, proportion of middle school students who plan to attend college. Okay, so hopefully you can follow along with that and see that we're doing that four-step process. You have to state everything out. You want to show everything. Notice we checked the 10% rule. We checked to see if we can use the normal approximation for all of this. Hopefully this is starting to clear up some questions that you may have been having about all of this. Write down anything that you didn't understand and bring it to class tomorrow.